Yo, helping you in your homework. What's up? With Mr. Newbold in the house. Yo, whoop whoop. Alright, here to help you on your math homework here, 2.5, Symmetry and End Behavior. We'll look at a few of these problems here. And maybe we'll start off with number 2. That looks like a decent one. So basically you have to do some writing notation there. And that notation is, so as x approaches infinity, what happens with y? And as x approaches negative infinity, I think usually we do those reversed. I think on my notes there, yeah, it'd be better to do that. So we're going to put positive infinity here, and then we'll change this one to, there we go. So as x approaches negative infinity, that means it goes to the left, basically on our graph. What happens to our range, our y values? And then as x goes to the right positive infinity, what happens to our y values? So that's what you do for part A, and that's called the end behavior. So let's see here. Well, here's our graph. So going to the left, it does go down, but then it goes up forever. And so that is going to be going up to positive infinity forever and ever. So we'll go and put positive infinity there. And then as it goes to the right, it goes also to positive infinity. There we go. So there's your answer for A. Did you get it right? Try B first. Okay, so B is the sign of the leading coefficient. And so that means, for example, this could look like maybe an x to the 4th, or x to the 6th maybe, or x to the 8th, whatever it is. We're looking for the the number that goes in front of that x to the 4th, right? That's called the leading coefficient, or if you're using x to the 8th, whatever the highest power is. So the highest power there, we did 3x squared plus 2, whatever the equation. We don't know what that equation is exactly. But we're looking for the sign. Is it negative or is it positive? And so let's see. Well, I'll show you on the video. Take a look at me. So x to the 4th, x squared, x to the 6th power is, if it's positive, it will go upwards. If it's negative, it will go downward. Both of them. And so since our infinity here is both positive, and we're talking about even, and we look at our graph going up positive, then that means this leading coefficient must be a positive. So your answer there for B is positive. Good. Okay, next we want to know if determine whether your graph is even or odd degree. So even or odd degree is different. So be careful now. So that's different than an odd, even, or neither function, right? So the degree is different than the actual function if it's odd or even. Because you could have like an odd degree polynomial that is neither even or odd as a function. Okay, so just be careful. So first we'll do odd and even degree. So since this is both going up, positive infinity, that means it's going to be an even function. X to the 4th, x to the 6th, x to the 8th. And then D, is it an odd, even, or neither function there? And so let's see. Well, we can do a test. And so the first step to see if it's even would be if it's reflective. So for example, let's take this side, reflective about the y-axis. So we're going to go ahead and flip it to the left. Boom! And is it reflective? Ooh, look at that. So the right matches up reflectively with the left. So we are going to say it's an even function. Okay? And so odd would be rotating it. So maybe we could look at an odd function. Not sure if we have one actually. Ooh, that looks like it could be odd. So maybe I'll jump to number 6 to help you. So an odd function actually has to be rotated 180 degrees about the origin. So like that. And then it does look the same. Okay, so in this case, this one's not being rotated around the origin. Okay, so I'm going to put down here. So it's definitely not even. It's not an even function. and it's not being rotated. Okay, so it's not being rotated around the origin. So what does that mean? Well, it's not even, it's not odd, so it's not being rotated around the origin, which would make it odd if you could. And so that means that this one is neither. Or according to a few students in my class, Landon and Dayton. It's what's it gonna be? Yeah, shout out to you guys. What's up? Neither. No, neither. Or if you're from Korea, neither. Cool. So then there we go. Because that's what I heard. Might not be true, but that's cool. Okay, so there's your answer there for number 6. Working our way backwards. So going this direction, if you do in your calculator, you'll notice that is some kind of like x cubed. Looks like it's maybe shifted up to 12-ish. And maybe moved back to the left a little. So not exactly sure. Maybe something like that. So we're not exactly sure. But it's definitely going to be an x cubed. And so an x cubed, that means that, let's see here. So then that means that the polynomial degree, so 3 is odd, so that means that the degree is also an odd degree polynomial. So that's the answer there. Part B, because it's flipped this direction and not this direction. If it started off high and then came down low, then that would be negative coefficient. That would be a negative coefficient. Just like look in your calculator and do like negative x cubed or something. Like I'll show you what I mean real fast. Some of you are still like, what? What is he talking about? So right now that looks like an x cubed with a positive. Well, it's loading. A positive leading coefficient. So for example, on our calculator there, we're going to go y equals. So we'd do something like 3x cubed, or another number that's positive, maybe just 1x cubed. And so you'll notice that those go start low and then work your way up high. Start low, work your way up high. Maybe we'll do one more that's kind of a bit more crazy looking. So how about maybe 9x cubed? Choo, choo, choo. Oh, looks like it's getting thinner. That's weird. Anyways, cool. So then let's see here. Oh, how would we make it? Maybe if we added something crazy like a shift upwards, like I don't know, maybe like a plus 2x squared and then plus 1 maybe. Let's see what that does. Ooh, that's cool. It makes a little thing there. So if we go ahead and zoom in, yeah, now we're making a little bit more like our problem there, kind of. Yeah, see how it comes up and then down and then up again? Yeah, so that's what this guy is right here. So it is a positive leading coefficient, negative. Again, negative would make it switch around. So what I mean there is if I did second insert negative, then that would make it, instead of going down to up, it would go up to down and then down. Yeah, and that's not what ours is. Yeah, ours is going upwards. So that's why it's positive, leading coefficient. And so that means if we look here, this will be negative infinity. Up here will be positive infinity. So as x goes to negative infinity, y goes to, as it goes to the left, we go down. So negative infinity. As x goes to the right, to positive infinity, y goes up to positive infinity. Yeah. So there you go. There's those two. Excellent. Should we do another video? We're still going. 9 minutes. We're nearly there. So we'll jump down and just do a couple more quick ones here. You'll see how easy this homework assignment is. Describe the end behavior. Ooh, so a negative x cubed would be something like that we just showed on the calculator. So going to the left would be positive, this direction. Going to the right would be negative, this direction, negative infinity. Good. The function is odd because of the odd degree polynomial power, which is 3. And the leading coefficient is can you see it right there? It's a negative leading coefficient. And so we'll circle negative because it's a negative leading coefficient. You can see over here now that this function is also an odd degree polynomial because the 3 is odd. And then this one is actually positive leading coefficient because that's just a positive 1 next to it. And since it's x cubed, we know that it goes like that. And so going to the left would be negative infinity, and going to the right would be positive infinity. That's pretty awesome. I didn't have to look at my calculator. It's crazy. It's crazy. So I'll jump down to maybe some tricky ones here. Let's see here. So maybe, yeah. So just to do kind of, now write it out like above. Yeah, so 13, you want to write it out. So x approaches negative infinity. Y approaches something. And then as x approaches, oh, in fact, we could write it over here. So y approaches something. And then as x approaches positive infinity, goes to the right, y approaches something. I'm going to take a guess, and then we'll look at the graph. So I'm guessing, because it's negative x cubed plus 2x, it's probably going to go like that. It's negative x cubed, usually looks like n, negative x to the 5th, negative x to the 7th. They all kind of follow that same end behavior. So it's going to be, as we go to the left, it's going to be positive infinity. And then as we go to the right, it's going to go down towards negative infinity there. And so we'll put negative infinity. What is it? The degree. And we wanted to know what the degree was. If it was, let's see here. So the degree, and so the degree of this polynomial is it odd or even is what I'm guessing we're supposed to ask. Do I remember? Let's see. The function is, odd or even degree polynomial. Cool. So that's 3, which is odd. So we'll put the degree is odd degree. So the degree is odd. Odd degree polynomial. Leading coefficient is the number right in front of it, so that's a negative and negative 1. Cool. See, these aren't too bad. They're not too bad. We can verify that by plugging into our calculator if you want real fast. So what we'll do there is we'll come over here to y equals. We'll type in a negative. Looks like it's just an x. Looks like it's just a negative x cubed. Cool. Plus 2x. Good. Delete that, so good. Delete that, delete that. There we go. So we'll turn off, we'll clear this one out. Because that's what the actual graph looks like for number 13. Cool. We're right. Up here is positive, right? So that's going upwards to the positive direction, to the left, and then going to the right is the negative. Does that make sense now? Starting to get, please, making sense? Yeah? Hope so. And if it is making sense, then after you graduate, then it'll make dollars. What? With your math knowledge and get your degree? All right, excellent. So number 16, I'm guessing it's going to do something like that, going downwards. So as x goes to the right, negative infinity, or just to the left, sorry. As x goes to the left, negative infinity, y will go to negative infinity. As x goes to the right, positive infinity, y will go to negative infinity. These both are going down. It is going to be an even degree polynomial this time because of the 4 with the highest degree, the highest power. And the leading coefficient is just a negative 1. Okay, last but not least, there's those ones. So then mixture view, don't forget to switch the x's and the y's. Solve for y, right? Remember that? Switch the x's and the y's, solve for y. Get 7 to the other side. X plus 7, we get y squared. Square root both sides. Don't forget the plus or minus. So y equals plus or minus square root of x plus 7. Sick. Just did that really fast because I wanted to help you there on some of the mixture view there. Excellent. I feel like that is doing something weird. Where did that graph come from? Oh, I think that was from that was when we were in class. Alright, excellent. So simplify those ones, expand those ones. Remember to use row 1331 for that one. Use your calculator, and so remember to put in the graph, go to second calc, go to intersect where the two graphs intersect. And so make sure that you do that intersection, or do it by hand. You can set them equal to each other. X squared minus x equals x squared minus 6x minus 15. And then we can minus x squared to both sides. So they cancel out. That's pretty sick. Cancel them out. And then let's see here. Move the plus 6x to the other side. That's a good idea. And then 6x minus 1x is just 5x. 5x equals, bring down the negative 15. And then divide by 5. That wasn't too bad, actually. So then x equals what, negative 3? And then plug it back into the equation. Negative 3 squared is 9. And then 9 minus the minus 3, so 9. So 9 plus 3 is what you're going to do there. And so 9 plus 3 is 12. So then we get x equals negative 3 and y equals 12. And there's your intersection. I can't see, I know, it's dark. So there's your intersection, your answer. Just helping us with the mixture view. Okay, last but not least, even, odd, or neither. So let's take a look at those real fast, and then we'll be done with the video. Kind of a long video, but wanted to help you out there. So let's see here. We'll jump to, let's try this one, because 26 looks crazy. So remember, all you're going to do is you're going to plug in a negative x wherever you see an x. Okay? So negative parentheses squared plus 2 parentheses. So wherever you see an x, right, wherever you see an x there, you're going to plug in a negative x in its place. So we'll put a negative x there, and then see what happens. And then we'll know if our function is odd, even, or neither. Let's see here. So negative x times negative x is a positive x squared. So we'll put down positive x squared. And then that negative does now come down. And then 2 times the negative x is a negative 2x. So then we compare that with the first one. So compare, compare. And so we're going to compare that with negative x squared plus 2x. And so let's see. So the signs, so it didn't go back to the original. So if the original problem was negative x squared minus 2x, then it would be even. Because the functions look exactly the same when you're done plugging a negative x through. However, yeah, this is a weird one. Because let's say you change the signs and make it odd. So that means it'd be a positive x squared and a negative 2x, changing the signs. So that would be an example if your original function, if the signs changed and so they were just opposite signs, that would make it an odd function, which this is not either. Because the negative x squared stay the same. The negative x squared stay the same, but then